Alright, moving on now. This is a special case here. Triangles. We're going to do the area and the perimeter of a triangle. Both of them are just variations on things we've done in the past. So for instance, let's just go ahead and do area first. A triangle is simply a rectangle cut in half. So if this is 4 centimeters and this is 3 centimeters, and we were to put a dotted line corner to corner, I think it's fairly evident that this half and this half are the same. So the area for a triangle is simply base times height. Let's just put a B here, so we're in an H here. And it's base times height divided in half. Okay, so there's several ways to write that. I'll write it several ways. Here's base times height divided by 2. Or I'm going to write it like this. Area equals 1/2 times base times height. Or area equals base times height divided by 2. All the same. Okay? So, what about the area of this one? Well, let's just do it. It is 3 times 4 is 12. 12 centimeters squared divided by 2. So in this case, the area is 3 centimeters times 4 centimeters. I'm going to make this a time so it really looks like it. Divided by 2. What does that look like? That is 12 centimeters squared divided by 2. That is 6 centimeters squared. So the area of this triangle is indeed half of that. Okay. How about the perimeter? The perimeter of a triangle is actually a little bit trickier. The perimeter is going to use the Pythagorean theorem that we learned in 1-6, because for the perimeter of this you're going to have to know the length of this side, the length of this side, and the length of that side. So let's just continue with this example here. So let's say we have a triangle, and this triangle is going to have a height of 2 centimeters and a base of 5. How long is that? Well, let's just call this the hypotenuse, which is that straight is the third side of the triangle. And for us, the hypotenuse is going to be equal to, here's the formula that we learned last time, the square root of this distance squared plus this distance squared. So what does this look like? Well, let's just go ahead and do the math. 5 centimeters squared is 25. 5 times 5 is 25. Centimeter times centimeter is centimeter squared. 2, we're going to take 2 to the second power of 2 squared, which is 4. Okay. Excuse me. And what do we do now? Well, you're going to take the square root of all that, but you're going to have to first add it together. So we're going to take, the next step is to say this is 29, 25 plus 4 is 29 centimeters squared. There's your answer, except that doesn't really look that useful. So we're going to have to do two things. We're going to divide this up into 2 parts. This is the same as the square root of 29, and I'm not even going to put a plus sign there, the square root of centimeters squared. Let's just do this first. If you square something and then take the square root of it, they're inverse operations. That cancels that, so you're just left with centimeters. And what's the square root of 29? Well, we could make some guesses, but that's why they invented these things right here. So we're going to say 29 square root, and that number is 5.38. Rounded to the nearest tenth, which is here, with the next number being the one we used to round, which is going to cause it to round up. That is 5.4 centimeters, and that's the answer. Okay, so what you've done now is you found the length of this last one. So now we have to go back and answer the original question, which is the perimeter. So we're going to have to add 5.4 plus 5 plus 2 to give us a grand total of 5 and 5 is 10. That's 12. 12.4 centimeters. The final perimeter is 12.4 centimeters.